Okay, here are the answers to the review sheet. If you haven't read the question yet, please read it over and try the question first before you watch the video. Part of the problem that many students face is making a decision of what type of test to use or what type of confidence interval to actually use. So try to read through these questions and try to find the key pieces of information that lead you to make the decision of which direction to go into. So read this over and make a mental note of whether or not you can be working with percentages or with averages. Now that you have read it over, you may have realized that the question really begins with the last sentence from the first paragraph. The other information there is background information that deals with percentages but is not used to answer the question, because it gets down to it in question A. It says to find the 80% confidence interval for the mean education level in the county. So remember, with our confidence intervals, there's 3 steps to it. The first step is to check the conditions. Was it a simple random sample of people? In this case, it was a yes. And do we have enough people in the sample? Is n greater than or equal to 30? And that's also true because we have 100 people. So the sample is random enough and it's big enough. The second step is to name the test or name the interval. This is a t interval because we're dealing with averages and there's only one sample. So it is not a 2-sample t interval or anything like that. It is just a t interval. And using the graphing calculator, you can type in the information that was given in the question, the average and the standard deviation, and the graphing calculator would provide to you the following confidence interval. And the third step is to explain what the interval means. The method used finds the true average, in this case 80% of the time. So we're pretty much betting that we were lucky enough to have an interval that actually locates the true educational level for the area. Now in question B, it goes on to say, we'll read it over, that the national average is believed to be 13.5 years of schooling for people ages 18 and over. And they want us to run a hypothesis test using 10% as a significance level. So we're using the same sort of information. This does mean that we're working with averages and not percentages. So we would be dealing with a t test to complete this. So the average for the nation is 13.5 years of schooling, and we're thinking based on what our results were from our sample that we have a smarter, in terms of years of schooling, population in this area that they're thinking about opening up the bookstore. So on with our 4 steps. That's the first step. The second step is to check the conditions. The conditions were checked before, and it's the same problem. So both conditions were good. In that second step, we want to name what we're doing. We're doing a t test, and the significance level was supposed to be 10%. All right, the third step, just using the calculator, we can quickly generate the t-curve for this and the t-score. and we find out using the calculator that the t-score is 1 on this t-curve. The shading would be to the right, that matches the inequality, and the p-value ends up being quite high, about 16%. The fourth step, the p-value is high. You're going to reject the ha in favor of the ho. So in taking a step back and looking at this entire page, you can see, if you take a deeper look at, that the answers to both Part A and Part B do agree with each other. In Part B, we just found out that we are in favor of the idea that the average from the area does match the true average from nationwide. In Part A, the fact that 13.5 is in that interval also tells us that it is very likely that our neighborhood population has an average that is identical to the national average. 13.5 is a possibility. So because of that, the decision to build the bookstore should probably be no, based on this evidence. For question number 2, if you read that over, you'll notice that it's involving percentages and only one single percent. He found out that 88% of his friends, of his 50 friends that he knows, have a cell phone. So for this question here, you'd be dealing with a hypothesis test as one possible way to answer the question. So the percentage that Andrew believes is 80% that carry a cell phone. Now Zach thinks that Andrew's wrong. He doesn't know which way he's wrong, but he just believes that he's wrong. So Andrew believes it's 80%. Zach believes it's not 80%. Okay, on to the second step. It's not a simple random sample. It was a convenience sample. He just asked his friends or people that he knew. Do we have enough in the sample? Well, 80% of the 50 should be greater than or equal to 10. And that is true. So the sample seems big enough in that regard, but 20% of them won't have cell phones, and that would be 10. Well, that also just clears the bare minimum for the number required. It's a one proportion z-test, because we're working with all these proportions, and we can use, let's say, 5% as our significance level. All right, the third step would be to use the calculator to generate our normal curve. And with the work there, you find out that the z-score is about 1.4. And the shading would be on both sides because of the not equal sign in the ha. Shading our p-value from both sides gives us a p-value that is about 16% once again. And from there we can make our conclusion. The p-value is high, so we're going to reject the ha in favor of 80%. So even though it was 88% in the sample, it wasn't big enough to make us change our minds about what Andrew believes. Now, in typing this in, be sure that you're using x as 44 and n is 50. And the 44 comes from 88% of the 50 students. When you type this in, the x's represent how many actually did.